Good afternoon and welcome back to Dr. Logic Awkwardly Does Logic. I remembered what it was I was planning to talk about in my next set of videos, proof theory. So we're changing gears from the sort of semantic notions of truth and validity, frame properties, and looking back to the sorts of things that we were doing. For those of you who've been around here from the beginning, way back in the mid-60s for propositional logic, and even earlier than that for the syllogistic. And that is coming up with a system of proof. Now, you might remember that when we were first talking about generalities of proofs, that I said there's kind of a scale that you can go on. On one side, you have loads of rules of inference and no axioms. And an example of that was our propositional proof system. And then kind of in the middle, you might have like roughly as many axioms as you do rules of inference. And that is what the syllogistic looked like. The modal systems that we're going to develop are going to be all the way on the other side of the spectrum. We are going to have a handful of rules. We're going to start off with just 3, but we're going to have infinitely many axioms. So this means that the type of proof system that we're going to be using, the notions we're going to develop, a lot of them are going to be the same. So like the notion of proof, it's a numbered list of formulas, every one of which is either an axiom or justified by a rule of inference. These will be the same, but the strategies will be different because we have fewer rules to work with. Before we get started, though, I'm going to give a couple of kind of general definitions, and these are going to be things that are fixed throughout what we talk about. Because unlike the propositional system and the syllogistic system, where we came up with one proof theory for one application, what we're going to be doing here is coming up with many different modal proof systems, all depending on what we take as our foundational axioms. So we'll talk about how these systems build on each other, which systems are inconsistent with each other, what's interesting about each system, why you would want to use one particular system over another, what sorts of applications there are. And this is going to occupy us for quite a long time. But first, general definitions that will kind of stay constant no matter what kind of system we're looking at, because you can't get going without some sort of foundation. The first one is the notion of an axiomatic base. So this just is a set of modal well-formed formulas. We'll just call it gamma if we have an arbitrary set of modal well-formed formulas. This is what is going to provide the foundation for our system. The way that you can then get different modal systems is by changing the axiomatic base. The rules of inference we're going to keep fixed, at least the basic ones. We'll derive extra ones, just like we did derived rules in propositional logic. But changing the axioms will then change the types of modality that we are able to talk about sensibly, and also change what it is that we are able to prove. So that's kind of the foundation that I want you to have, just this one definition of the notion of an axiomatic basis, and to have a sense of kind of where we're going to be going from here, because there's going to be loads more videos of definitions. So until then, take care. Join me next time. Cheers.